never trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
All right. Hey, everyone. I hope you had a great Thursday. Almost the weekend, which is great. And then next week, obviously, we have the Thanksgiving holiday here in the U.S. So, yeah, I mean, the holiday season's coming around really quick, and surprisingly, the end of the year, too. So tonight, we'll be taking a look at kind of continuing what we did on the last stream. We created that Flask application, that web app, and we'll be now looking to create a persistent data store. So basically a database that we could store some of these results. Because remember, what we're doing now is we're clicking a button, it's going out, Scraply goes out, connects to the network device, captures data, and then returns it to the user, like the parsed information to the user. So what we're doing now is we're going to try to, instead of just parsing it out and then returning it to HTML form, we're going to actually store that data in a database. And then on top of that, and hopefully we get to this point, we're going to build an API to where instead of logging in, going into a web page and clicking buttons, you'll actually be able to hit this as an API endpoint and pull that data without ever having to go to this web page. So really, the nice part about an API is you can build another application that can interact with this one. So let's say, I know right now all it does is basically grab the software version, right? But let's say we build this thing out and it does it really well. It does some task very, very well. And instead of us, reinventing the wheel in our new application, we want to use this application to pull, let's say, the software version. this API will allow you to do that. It will allow you to pull that information from this tool and bring it into your own. So that's the nice part about building an API on the back end, and that's why I think you hear a lot of new. I shouldn't say really new, but like a lot of applications these days, you hear everything's API driven, right? You hear that those buzzwords, but it's not really a buzzword. It's it's true. A lot of these applications are built with an API that services, a bunch of different services can talk to. A web front end, other services, other tools, a public API that the a user can authenticate to and pull data. So very cool, and definitely the future. So tonight, like I mentioned, we're gonna build this into a database backend, and then hopefully kind of build up a preliminary API. So to do that, I actually looked through the requirements file. Remember, this requirements text file I got from the DevNet Expert site, and so you'll notice that Flask is on here, but the library that we'll be using tonight is not, and it's Sql Alchemy, and specifically we're using the Flask extension, so it's Flask underscore, I think, Sql Alchemy, and Flask is on here. Obviously that the extension is not, and then Sql Alchemy actually isn't either. So I kind of thought about it. I was like, worst case, what we kind of learn here is how to build the database, right? And how to most importantly interact with it from a Python perspective, right? So and we'll review that. We'll review some documentation. The coding shouldn't be as much as last time. Like the last stream, we did a lot of coding, and it was Python, HTML, JavaScript. No, we didn't do any JavaScript. But there's a lot of coding in the last stream. This one, there'll be some coding, but a lot of it will kind of be us kind of learning together. And I will preface that I did some prep work, but there's definitely going to be some points where I'm going to get stuck. But that's the fun of it. So, all right. So I mentioned the different libraries we'll be using. So I guess before I jump into Flask, Sql Alchemy, which is, like I mentioned, the extension, this is the primary library, and it's called Sql Alchemy. And so you can use this with anything. You don't have to use Flask. I guess that's kind of what I want to start with. But you could use almost any sort of Python library. This is just, like it says, an SQL toolkit and an object relational mapper. This is a mouthful, and if you were here for any of my the streams where we worked on my NetCheck project using SQL Model and Fast API, I kind of went over what an object relational mapper is, or an ORM you may hear as well. Basically, think of it as the glue that allows you to translate, that basically connects Python to SQL, right? So if you're familiar, SQL has its own kind of syntax, and we won't go over that tonight, but if you're interested, obviously, just look up SQL language, SQL syntax. I'm sure you'll find, your select statement, select from, all that jazz. But what this object relational mapper, ORM, does is it actually maps Python objects. So think specifically what we'll look at tonight, like Python classes, methods, dictionary list, and it actually converts that Python object to something that can be used in a SQL database. Okay, because otherwise you would have to think of it, if we didn't have an ORM, we would literally have to connect to the database over some sort of Python library to the proper database port, and then we would have to run actual string, we would have to put an SQL statement in there or a syntax. So you'd have to actually know SQL and do select whatever star. So you would have to be very precise. And on top of that, you'd have to make sure you don't have any sort of typos, errors, or anything like that within the SQL statement. So there's a lot that could go wrong with that. But like I said, this ORM is going to help us out a lot. And that's kind of what that's what Sql Alchemy is. And so the Flask Sql Alchemy is obviously an extension of Flask, so it makes it easier. There might be some added bonuses, but we'll kind of go through the quick start with that. But I wanted to lead off with what Sql Alchemy is and kind of the purpose of it. So hopefully, like I said, you can read through this, and you might connect with what they have wrote up here, and kind of going through this library. But if not, hopefully what I said made sense. But I just wanted to show you kind of this page. But what we'll be focusing on tonight is the Flask extension of it, or the plugin. Anton has a question. Why not MongoDB then, or other object-oriented DB? Good question. So you can use other relational databases, which we'll see here in the library documentation. The reason I'm using Sqlite is just because of the simplicity of the database, since it's just in a file. And you'll see we're not putting, this is obviously all for just testing and labbing, so we're not putting anything into production here. So hopefully that answers your question. But so let's take a look. Like I said, we'll start from the top with this and kind of just start using the code directly from this quick start guide, and then we'll modify it to what we need. So my original thought was just to prove and kind of figure out what everything is and how to get it working. We'll just take the two items that we store, that we pull from, let me see, that we pull from the device. So in our case, it's just the host name and the version. What we display is the host name and the version. So I figure, I know it honestly doesn't have, it's not needed for a database because it's only going to be 2 columns, but we'll do a hostname version. And then maybe what we'll do is also get the date that is executed, or the date time that's executed. So that way we have an understanding of, okay, when we collected it for this device, we collected the software version, it was running this, right? Obviously, with the software version, you don't upgrade those or change that often enough, but just looking to kind of experiment with it. Harshad said, "Can Sql Alchemy work with other databases like MySQL?" Yes, it can. Let me pull up the guide, and I'll just show it. I'll just show this real quick to you. This is the quick start guide. Let me go to the home page, and then simple relationships. I'm trying to find, there's actually a page where it shows Sql Alchemy. So I know MySQL is in there. I literally, it's crazy that I just saw this before the stream. Like, I saw it had a list of the different databases. But yes, to answer your question, MySQL is included. And I apologize, I can't find. Let's see. Maybe let's go to configuration. Okay, so they're using MySQL here. I believe, yeah. Connection formats. Here we go. So, yeah, Postgres, MySQL, Oracle, SQLite. So those are kind of the different formats or different examples that they provide. So, obviously it answers your question, but if you had any other question marks about, what other database it supports. Yeah, should be as well as Postgres, MySQL, Maria, and so. Yeah, so Anton, I knew it supported MySQL, but I also wanted to provide this list so that way you could. Yeah, no worries. Didn't mean to throw the stream off. No, you're not throwing off the stream. That's part of the experience, man. That is part of the experience. Yeah, don't worry about it. All right. So, like I said, I actually had to create a new Python virtual environment because Flask SQL Alchemy wasn't in my original one. And so I need to import that into my main app, which we, like I said, started on Tuesday. Right. All right, so we got that imported. So then we also have to kind of initialize the database and pair it with the application. And let me just pull that back up. Yeah, so here, I pretty much have the same code. I initialize the app. I add in the database URI, which basically is, we saw in the configuration tab. It basically just points to where the database is. Right. And so we'll just copy these two lines here. Right. And then, so I learned actually from a tutorial here, we had, so 3 lines, 3 forward slashes on Linux stands for kind of a relative path, whereas the fourth line is an absolute path. So what this does is, if I kept it as is, it would basically go and put the database in this path, /temp, the temp folder basically. Which in our case we don't want to do that. We actually want to put it in the local folder. We just want to put it right, basically within the same directory. So what we're going to do is just get rid of all this, and we'll just say test.db. We'll keep it test.db. That's fine. And then we create the Sql Alchemy object. So now at this point, we have the database initialized. We have it included in our app configuration. And so, once we create it, we should see it pop up right in the same directory as app.py. So we'll save that. And now it's time to make a database model, right? And what this is basically, this is where the magic happens. We got Sql Alchemy that, like I mentioned before, maps Python objects to basically objects or content that SQL can read, and you can interact with SQL databases. So we have the database initialized, right? Now we need to add tables to that database. And the way we could do that is by declaring what are called models. And think of it as, you probably heard the word, you probably heard data model. And data models are used to validate and provide structure to your data. And the database model is a little different. It actually, you could call it a database model, or more specifically a table model. And what this will do is it will literally model what your table is going to look like in your database. So we're just going to grab, we're just going to grab this and we're going to modify it. So I actually went through and created, you could put this right in your main code, but I try to keep everything pretty clean. So I segment things up into different files, and this will also allow you to scale this app as well. So if, let's say, you wanted multiple tables with multiple, using different models, then you could put them all in this models.py file. So you declare the table. I'll call it a table or a model. I mean, you might hear that interchangeably from here on out. But what we'll call this model is just called, we'll just say device. db.model, this actually comes from this db object here, which, like I said, it's a variable assigned to the Sql Alchemy object. Okay. So what we actually need to do is, in order to use this db, we actually have to import it from app. So we'll say from app import db, right? So now we have this db object that we imported it into models, so that way we can use it. And what this is it allows us to inherit from the base model class that is in the Sql Alchemy library, or in the module, I'm sorry. So hopefully that makes sense. And so I kind of outlined it here. Maybe I'll do it a little cleaner. We'll say ID is going to be an integer. And we're going to say date created. It's going to be date time. Oops. So I tried up here, you'll notice, I'll just keep it all lowercase to avoid confusion. So I tried to make this as simple as possible by kind of being verbose about what the model and what the table is going to look like. So we're going to create a database table called device. And within that table, we're going to have an ID, which is auto incremented. So think of, I mean, if you look at almost any database, it's going to have an ID, whether it's like a string of values, or randomized values, or more commonly just an auto incremented number, right? So start with 1, 2, 3, 4. And what that allows us to do is ensure that it is a unique record, right? Because with relational databases, you have to have something called a primary key, which is basically a value that allows you to signify how is this particular record unique compared to all the others, right? If I tried using version, obviously we couldn't do that, because if we have 10,000 devices and 1,000 of them are the same device model, we most likely are running the same software version on the same device model, right? So we're not going to be able to do that. Hostname, this should be unique, but let's be honest, there's going to be times where we accidentally add in the device, or try to add in the device twice, or maybe there are host names out there that we don't put our host names in DNS, and we can have duplicate host names. So that could be a primary key, the host name, but we couldn't use that. So anyways, for some simplistic purposes, we're just going to use an ID, an auto incremented ID. And then lastly, the date created, obviously that's going to be dynamic based on, technically that is most likely will be unique. Now there are times where records could be created at the same time, but we'll keep that as is. But ID will be our primary key. So you'll notice, we can keep the first line. Perfect. And I'll quickly run through this. So we have the name of the column, ID, and we're, DB. If you see anything prefaced with DB dot, remember that goes back to this object that we created, this Sql Alchemy object, or instance technically, but we created it over in app.py. So anywhere you see DB dot, it's referencing that. So it's referencing the Sql Alchemy library. So that's where you see like dot model, and then you'll notice there's different. I'm sorry, we started here. We specify our columns. So the reason, databases obviously have columns and rows. Rows are your actual records where that data is populated, and then your columns are defining what data should be in those, in the specific column, and so that way all the records, look the same. You don't have ID in your third column, whereas in your, second record, it's in the first column. It would be silly. So we're defining the columns, And then this first value we're passing in is actually going to be the type, the data type. So within a table or within a database, you can have different data types. And this can depend on the database. Some databases allow for even like JSON values. So, we went over JSON in just previous streams. I can't remember like if there's an exact moment in time, but we've definitely looked at JSON data before. And so you can actually store that in, I believe, a newer version of Postgres. But, your traditional programming data types are about the same as your database type. So integer, string, let me just pull them up so that way we're not guessing. There'll be different types here. Let's see. Overview. Multiple databases, model class. That's the model class, the query class. Oh no, we're gonna get to this. Simple relationships. Once again, this is one of the things, like I saw this, I should have had open tabs, I swear. I saw like a list of the different data types. But anyways, we're not gonna, but just know, there's string, integer, float. It's not called float though. Because decimal essentially. Date time is one. So yeah, anyways, there's a lot to the different data types. But anyways, we'll, kind of just move on. So we have the ID, so the integers, the data type, obviously because it's an auto incrementing number. And then primary key equals true. Obviously we talked about primary key. This is kind of that unique value that makes the record unique. And so that's the first column. The second column we're going to call host name. And we're going to say a host name can be up to, I'm pretty sure there's a limit. I forget what it is for Cisco iOS. But let's just call it 50 characters for a string. And it's not unique. Or no, it is unique, but why? I don't think I need that though. Let me see. No, I don't need that. Yeah, I don't think. We already created the initial data, or we still got to create the initial database. Back to here. Let's get a model class. These are the, no. Oh, where was that? There we go. API reference. I don't need query. Models, here we go. Columns. I must be missing it. No. I must be missing it. I was trying to see if there's any sort of documentation around the different parameters for the columns. Multiple databases. No, I don't need that. Declaring models. There we go. Oh, see, I mean, finally found the page. Here are your different data types for your columns. So, you know, I just kind of mumbled over it there, but integer, string, text, date time. Okay, so float is one. Boolean, pickle type, which I'm like, I don't know what pickle type is, and then large binary. So, yeah, so there's your column. If you want to use a different name, primary key, there's your different columns. Okay, so it more or less explains. I kind of wish this was more in like a reference document instead of like paragraphs, but so since person with no name or email makes no sense, nullable equals false tells Alchemy to create the column with as not null. This is implied for primary key columns. Okay. For all of the columns to make it clear to other people working on your code that you did actually want a nullable column and did not just forget to add it. Okay. So technically, we probably do on this. The unique value. Now, what's interesting is unique. That's all that is in here, though. Okay, so we'll definitely add the nullable back. We'll just say unique is true for that one there. Okay. So, all right, so we have host name. It's going to be a string, no more than 50 characters. We'll call it unique, and we'll say it's nullable equals false. So that way, if it's empty, we can say, it would just say not null in the value, as the value. So the next one's version. And so the version, I guess we'll keep it at 120 characters. The problem is, so the version can be just numbers, or it could be a mix of numbers and letters. But I don't want it to be 100 characters. I mean, that one should be no more than, we'll do 50 as well. I hate doing that though, because it shouldn't be more than like 12. But we'll do 20. We'll do 20. Nullable equals false. I feel like I need it here. I need it to be included, so we'll do that. And then the last one is going to be called date created, and we'll say db.column db dot, I think it's date time, yeah. And let me see. Actually, I gotta put that as a capital, and default equals. So this is where I gotta import date time. From datetime, import datetime. And the datetime library obviously is providing the date and time in a specific format. So we'll do datetime dot net. Jeez. Now. And we don't need to include the double parentheses, because this method will be executed whenever the record's created. Okay. All right, so our model's done. Our model/table is done, ready. And now what we have to do is create a record. Create a record, and well, create the table and then create the record, right? So let's first create the table. And now I'm lost in my own tabs. It should be right here. Yeah, so create the initial database. Basically go to a Python interpreter, import that DB variable that we've, and by the way, this variable, it's named DB, It could be whatever. Obviously, DB is easier to understand, or you can type out database, whatever. But it could be whatever. I'm just using what's included in the quick start guide. But what we'll do is import that DB object into the Python, the interactive shell, and then run the create all command. And what this will do is actually create the database, hopefully. So make sure I'm in the right folder. So we'll say from app, Python. All right, so now we're in the interactive shell. So we'll say from app import DB. Let's see, Sql Alchemy track. I think we want to call that false. App.config. I think you set that to false. Let me just double check. Oh, set it to true or false. Okay. Let me try it again. From app import DB. Okay. So the reason I set this up, actually, it's funny enough, I actually saw this whenever I did read some of the documentation beforehand, and I saw that they do recommend disabling this because of the significant overhead, as this warning message mentions. So that's all I did, was I added this to the app config and just set it to false, because I guess out of the box it's true. So we'll do db.create all, which should create the database. So you should see a new file called test.db pop up, probably like right here. There it is. Perfect. Okay. So now let's throw in a quick record. How about that? So let's follow our model and create a quick record. So we'll say, let me follow the quick start guide again. All right, so basically we're just got it. So we'll just say device 1 equals device hostname equals I know I have one called R1 and stream switch, so let's just do like R100 for like router 100, and we'll say version equals, and we'll just say 17.3.3, right? Because that would be like a newer iOS XE router. So we'll do that. Oops, I forgot to import. Yeah, I forgot to import the model. So, which I thought it would probably fail. So all I'm doing is saying, oh, hold on, has no attribute date time. Thought for sure it did. Let's try it again. Interesting. I thought. Yeah. Oh, date time with a capital T. Let's see if that makes the difference. Date time. Save that. Let's try to import this model again. Oh, sure enough. That's all it was. All right. So now from models, which obviously we're in the models py file, we're importing the device object, or I'm sorry, the class or the model, as in our case, and we're creating that object, and we're passing in the parameters that are required. So ID is not required because that will be auto incremented, so we don't have to pass in like a ID equals 1. And then date created is automatically, it has a default value, which is the date time.now, which is pretty self-explanatory. So we only really need to clarify the host name and the version, which we did here. and they're both string values, which is why we have the quotes. So we'll do this. We'll say device 1, and then we'll create another one. Because honestly, I only have 2 devices to add into the inventory, like actual devices we're going to be interacting with. So we may just create like, we'll just say these ones are running the same. And then we'll say there's another one, 3, which is, let's just call it an NX switch 1, and this is running, man, it's been a while since I've looked, but like, let's say 9.3.2 is the software version. Okay, and actually we'll preface this to say NX 9.3.2. All right, so we have the objects now. We've used our model, our database model, and we've created the objects, right? So what else do we have left to do? We have to add these devices to, think of it as like adding it to a queue, or like if you've used Git, think of it as like staging your changes, right? So like you make the changes, you save them, and just to show you, like we have the changes here that we've done so far tonight. And if we wanted to stage them, we have to click the little plus button, or in the Git CLI it would be git add, right? So we have to first add these changes, and then to actually save them to the database, we would say but we would commit them. So it actually uses the same kind of verbiage, add and commit, but it's not related. So let's just create quickly another, we'll create another terminal, and we will take a look at, we'll look at the database as is, okay? So the way, you have to have SQLite installed, and you can just use like apt, like I'm running Ubuntu 2004. So you would install this like you would any other package, and so you would do apt install, and then you would install SQLite 3. So once you have it installed, you can then use the command line to interact with the database. They do make a really good, shoot, I forget the name of they make a good GUI application that you could like, open up the GUI interface and interact with the database there, but since our database is so small and the command line is pretty easy, we'll just use the command line. So we do SQLite 3, name the database, test.db, and now we're in the interface. So it's kind of weird. SQLite, the commands all start with like dots. So we'll do .tables, and you'll notice that there aren't any tables yet, okay? And that would be because there aren't any tables because we don't have any records, okay? So basically what I did here, hold on, let me do this. I think it's, let me just make sure I have the right thing. Databases, maybe that will be it. Okay, so remember, databases is first, and then within it, a database can be multiple tables, right? So right now we have a database, it's just a, main, and it's just, because we're using SQLite, it's literally a .db file, but like Postgres, you would name the database and you could connect to it, over a port. But in this case, we're just connecting to a file. So the database is created, which whenever we did create all, it did pop up, the file popped up. Now we have to create the tables, and the table's not created yet because we don't have those records in there. As soon as we put in records and commit them, the table will be created. So let's do that now. Let me pop up to quick start again. So you'll see here db.session.add. So we'll just pop that over here. And what are we adding? Well, we're adding device 1 through 3. So we're just going to do it sequentially. And let me pop back over to the right terminal window. So we'll add device 1, because remember, all the records that we're trying to add are in these variables now. Device 1, device 2, device 3. So we'll do add. We'll say add device 2, and then add device 3. So now we'll just do session commit. And I'm pretty sure, I know you can definitely commit more than one. Yeah, you just call commit. You don't actually have to say commit device 1, device 2, device 3. I just wanted to make sure. Let's see, values created, insert into device, hostname, no such table device. Let's see. Let's see, I must have missed where we actually create the table. Interesting that Prisma provides a class, because normally you should be able to create the tables and the database. Interesting. No such table. So it's saying we don't have the table, but weird. Okay. So we import, to create the initial database, import the DB object and run the create all. It creates the tables and the database. Oh, you know what? I wonder. I wonder if I have to import them here. Hold on. From models import device. Let's see. Insert into device instead of insert into device. It's trying to insert like the uppercase D for device. No, so what it's doing is whenever I create this model, so here, let me just try something real quick. We'll start over. How about that? Ooh, what the heck? Did not mean to do that. Let me delete this. That's the nice part about working with SQLite, is because if you screw something up, you just go through and delete the DB file. So what we're doing is saying from app import DB. Cannot import DB from partially initialized module, most likely due to circular import. Oh, yeah, it's because I'm importing it from here. Shoot. Yeah. I thought I had to import the model. Oh. I know what I have to do. Hold on. I'm making this purposely hard on myself. That's what's happening. Let's try this. Import from models, import DB. And device. Try this again. I'm making it difficult on myself. Basically, I'm putting this app this should be in this first. I'm basically making it hard on myself because I'm putting the device model. I'm putting those models in a separate file, and it doesn't like whenever I'm importing it into the class. But I'm thinking that's what it is, though, is that for some reason, because yeah, when I do that and then do import.create all. All right, so the DB's there. Now let's do. Let me just exit this. Scrap that. Create a new SSH here. See what the error message is again. DevNet Flask. Oop. And then auto. And then we're gonna try to connect to this guy. Test DB. Yeah, so like that's a little confusing. So by default, this should. I'm gonna figure this out. So let's see. And you want to create all to create the tables and the database. So what our problem right now, right, is we are not creating the. It doesn't create the tables. It's just creating the database. So that's kind of the problem. Let's see something. Let's jump over to this API. Creates all tables. Doesn't really help me, does it? So I know what will work is if we move this model. Watch. Well, I mean, I guess we can just see. Is if we move this model right here and we trash this, or I think you can just say exit. Yeah. And then let's delete that. Oh no, what did we just delete? Oh, shoot. All right, let's revert that. Discard changes. Are you sure you want to restore app? Yeah, let's restore app.py. That's what happens when you're rushing things. All right. Oh man, did it really take out everything? Great. All right. Luckily, we didn't get that far in. Man, that would have sucked. So we'll just take out, this is what was here before. And then there was one other thing that was test.db, and then we had a class here. That could have been catastrophic. Harshad says I was screaming no at my screen. Hey, I'm just glad, you know, we're in the safety of my lab. So, all right, let's try this again. So we'll jump back into the Python interactive shell. We'll say from app import db. SQL is not defined. Oh, because I didn't import it from Flask or Forgot the import statement. Of course. Of course. Let's try this again. Oh, and then I have datetime. I don't have from datetime import datetime. Alrighty, let's try this again. Alright, so there's that warning. I just need to do this real quick. And app.config, and then we'll just set that to false. All right, let's try this. Let's try this again. I feel good with it. db.create all. Wait, I didn't even. Oh my gosh. Let's try this again. I've deleted the wrong file. All right, let's do that. All right, so we recreated the test.db file. Let's open it up. SQLite 3 test.db tables device. Okay, so, and you can see that here. We now have a device table. The problem was this device table wasn't in the same file as where we initialized the database. Okay, and I was having issues with the import. I might try to fix that. There's a good chance though I might just keep it like this, and this will also help you understand, like, if we keep it on, I mean the file's obviously not that big, but I will say in a disclaimer for anyone, you know, watching the playback of this, you ideally, if you wanted to build this out, like let's say you took this code and you're like, all right, I have a lot of ideas. Dan got me started with the Flask app and getting it working. If you wanted to build more database tables, you would want to put these in its, you know, this in its own class or its own file. So that's where the kind of the models would come in. But because we're not using it, I'm just going to delete it. And like I said, what the problem was, just to clarify, the problem was related to the import and how the database got initialized through that create all method. It was looking for this class, but the problem was when I was importing it, what happened was it was a looped import because we were importing this device class, which then used the DB class, or I'm sorry, the DB object. So it just kept, it was like an import circle, and that's what that error was. Hey Clay, so Clay's saying install the SQLite plugin for VS Code. You can browse the DB in the UI. Yeah, let me do that. I think I already have it. SQLite. I'm pretty sure. I thought I had it. I'm guessing it's this viewer. Let me see. Oh, you call it SQLite. Yeah. Let me see this one. Just trying to figure out which one I like the best. I kind of like the viewer though, because the viewer was, you clicked on it, as long as it had the SQLite extension, which I can change the extension, that's not a problem. Yeah, let me just install that real quick. And if it doesn't work, now I'm using WSL, so hopefully it works. What we'll do is just call it SQLite. I think it should be SQLite 3. Should be the true extension. But yeah, let's try it. Get rid of this. Shouldn't hurt, but maybe I gotta let me re-import it from app import db. No, I'm just gonna try. Delete. All right, so we'll do from app import db, and we'll say db create all. There we go. All right, now let's see if this extension works. All right. Awesome. Well, this extension's neat. I had another SQLite extension that was real wonky. For some reason, it wouldn't open. I had to use like my file explorer, and I had to get to the WSL files, and for some reason it wouldn't open. So this actually is much nicer that it can just open within VS Code. So yeah, appreciate the recommendation, Clay. So yeah, here's a really good example. So once we start adding data, which I'm actually going to begin doing now, going back to, I'm just going to go all the way back. There we go. So I'm going to add these devices, the ones that we originally were going to add to the database. And as I do that, I don't know if it'll update in real time, but we'll find out. So we'll do, oops, from app import device. So all I did was I had to import the device model, because since in these, you can see here I'm declaring device class and passing in the hostname and version. So we'll do that. And let's just say, I think we said, 200. And then we called it device 2. And we'll say device 3. I think this one we said it was going to be a Nexus device, so we'll just call it like NXV1 or NX switch 1. And then we said we were going to do NX 9.3.2 or something, because we want to, obviously, like 17.3.3 is like iOS XE, but like let's say we wanted to add a Nexus device, and for whatever reason it had a this NX prefix. Let's see if it works. So now we'll do db dot session dot add. I'm pretty sure that's what it is. Let me just double check. Yeah, session dot add. All right, so we'll do it for that one, we'll do it for this one, and we'll do it for this one. So now we have them all staged. We'll now do a db session commit. Let's see. Might have to refresh it. Refresh button. Boom. All right. Progress, everyone. Progress. So yeah. So we have it. We have the records added. You'll notice a few things here. You'll notice we have the IDs are auto incrementing 1, 2, 3. The host names are what we put in. The version. These are all. Remember, if you want to understand, like, okay, well, what makes a valid host, what doesn't, like, you can go back to the device, that model, right? And we can say, okay, well, our versions can only have 20 characters, and then our host name can be up to 50. Obviously, I mean, I think these numbers are kind of big, but I'm just going to keep them as is. And then the date created is the last auto incremented, and it defaults to the datetime.now format, which it looks like I don't even know what placeholder that is, but that is pretty deep. But you can notice there is a slight delay in the commit, because remember we added those, we created that queue. We did device 1, device 2, device 3, and you'll notice 201, 202, and I mean you're talking, this is seconds, all happened within a second, and you're talking like the tens, hundred, thousands place. I don't even know, micro, nano, whatever second. But you get the point though. This can keep track of when the devices were added. So I get the last piece that I want to do, and I know that took much longer than I expected it to, but that's okay. There's a chance we may not get to the API this stream. We may be doing that in the next stream, because I do want to get to that point, and I want to make sure we can do it the right way, and we have the database and all this, because ultimately the API is going to query the database. We're going to query the database on the back end and then present the data in a nice JSON format. So I want to make sure we get this right and get it solid, and then we'll kind of flip to the API altogether. So, all right, so now we have the database. And what my plan is, how about every time, obviously, like from a procedural standpoint, it may not make sense, but kind of just roll with me on it. So if we pull up, just so we can just copy the terminal. Maybe not. Whatever. So what I'm going to do here is run the application, so that way you guys can get a feel. Hold on. We actually don't need this anymore. All right. So I'm just going to run the web app now, because we're done with the command line, right? And by the way, this is kind of precursor what we're about to do with this function here. So ultimately what we're going to do is, when the user plugs in the host name and or wants to get the version of the host name, along with showing the user in the web interface, it's also going to store that data in the SQLite. Or I'm sorry, I may have just said that backwards. When the data gets shown to the user through the HTML web, the web UI, on the backside, it's also going to store those results in the SQLite database. So ultimately, anything that you see in the web UI, you then can pull later from this SQLite database via an API, right? Pretty cool. So we'll go back to these commands or using some of this code here because obviously it's a Python interactive shell, so works in the shell. It's going to work in our script. But I'm going to go ahead and I started the server. So just to kind of show you what I'm looking at here. So by the way, this is the home page. I haven't done anything since Tuesday with the home page or anything like that. But we do have the show version link that's going to collect the software version, and you select the host from the dropdown. This dropdown, and this might be something I look at off stream, is you can, if we had, let's say, another table in the database called like inventory, we could actually dynamically pull just the host name, the records in the host name column, get it, or IP or whatever. And we could actually have this list dynamically update to what's in the database. So, I mean, that goes back to, okay, that's cool and all, but like, what if I use Netbox, or like there's different sources of truth that you could dynamically pull, and with a little bit of JavaScript magic, you can get this thing to update as, these, as your inventory grows or you remove devices or whatnot. So, but anyways, this obviously is getting pulled from our static inventory file, that I've showed before, this config file. That's where this device list is coming from. So let's say, R1, we get the version, and it goes, like I said, in the background, Scraply goes out, connects to R1, and then pulls its version and prints it out in a somewhat nice format. I added this little ASCII art arrow. It's cool, I guess. But what we're on the back end, what I want to add is on the back end, I want to grab this host name and then grab this software version here and store it in the database. Okay, so that's what we're about to do. Let's go back to our code. So when we click get version or click that button, this code here is executed, and you'll see, it's a post, and then it redirects the user to this results page, which is what you just saw with the nice little arrow, the host name arrow, and then the version. So what this does now is it grabs the host name and then passes it to this, utility, what I'm calling a utility function, where it goes out, uses Scraply, grabs the iOS version, and stores that version in this host version variable. So on top of that, let's do this. Let's grab, we have the values now. One called, the host name is stored in a variable called host, and then there's the software version, which is stored in this host underscore version. So what we're going to do is say, okay, well, let's see what we did back here. We created a variable, and we'll just call it store device, and we'll say, okay, we want the device model, right? And we're going to pass in the parameters. We're going to say host equals, and remember, we're pulling the host name from the form, which is that drop-down menu, and we're assigning it to this host variable. So we're using the word host a lot. That's why I'm going over it very verbosely. So host name equals host, and then the version equals host version, because remember, this host version basically holds that 15.6. Or whatever that version that popped up on the HTML page. So it's a string value. This is a string value, and so this basically assigns those values to this device model, which is then understood by the database and allows us to store it. So let's do, we have the data, now we have to add it to the database. So we'll just do db.session.add, and we'll just say store device. I'll even be, I hate having variables that long, but I want, if someone's reading this, and I'll write some comments as well after stream, but so that's pretty much it. So what we're doing here, and there's no, I will preface, there's no safeguards in this. We're basically saying, okay, whatever we get back, if host version is some wonky like string, it's not the actual iOS version, then that's getting stored in the database. But yeah, we're staging the changes. We're adding it to that quote unquote queue, and then we're committing, and the .commit is where we actually save the results to the database, right? So now that's saved, it's committed, and once it's done, we'll then return it we'll still return it to the HTML form. So on the front, if you're a user of this application, you're not going to notice anything different. It's going to be the same. But I will say we should see one more record pop up down here. It should be ID 4. Host names are going to be R1. Version is going to be 15.6 whatever. And then the date created obviously is going to be way different than these guys. Probably a few minutes apart at least. So we'll go to show version. We'll say, let's do R1. We'll say get version. All right, see, so from the user perspective, nothing changed. I can still use this web app and say, oh, okay, like nothing really changed, right? Now, if we go over here to the table, you'll see that we have a new record in the table with the date, time, the software version, the host name, and then the ID. Harshad asked, does it do a check before inserting into the database to see if the devices already exist in the database? And if so, run an update instead of an insert. So like I mentioned, that I know in so the other application project I'm working on is called NetCheck, and it uses SQL Model as its ORM, and there is a refresh method that kind of basically is like updating. Like I said, I don't know. I have to double check the documentation for the error handling. Let's just see what we find in the documentation. That's a good question. The add functions adds it. It will issue an insert. So the add function does the insert. Before you add it, it basically does not plan on adding it to the transaction. That's good. All models should have a constructor. Make sure. Well, based on, I mean, this is not their quick start guide. This is their actual guide or documentation is saying, you know, create the Python object, add it, and then commit it. The add function call then adds the object, an insert. Yeah, gotcha. So maybe we'll need to manually add a check for existing records. Yes. And actually, funny enough, I passed it down here. You can do something pretty simple, and there is actually a pretty simple check that you can do, and is to filter. And this is actually something we'll look at whenever we build the API section. Google for Upsert. Okay. I will do that, Clay. Let me just find one of my pages that I'm not using. Sql Alchemy Upsert. How do you do an upsert? All right, I have a record I want if it is not there. This is often called an upsert. Yes. Sql Alchemy does have a saver update behavior, which in recent version has been built into .add, but previously was this separate saver update call. This was not an upsert, but it may be good enough for your needs. So it looks like it was built into session.add as of, I mean, hold on, this was answered in 2011. Sql Alchemy supports onConflict with two methods: onConflict, do update, and onConflict, do nothing. So this is kind of where, okay, here we go. So this is from the actual SQL documentation, and this, as you can tell, is the legacy version. So I imagine there's newer, and this method may have been deprecated, and they might have something better. Let's see. And so this is actually something good. Should be an exception. Anton says, should be an exception thrown as hostname field created as unique. Yes, you're right. Based on what I'm reading from a mixture of the Flask SQL Alchemy and also with this SQL Alchemy documentation, there will be something thrown, because why else would you specify it's unique? You know, unless there was some sort of exception handling with that. Clay says, sorry, not trying to tell you how to run your stream. I'm just on mobile, so typing is hard. Hey, Clay, you're never interrupting my stream. If anything, you're teaching me some things as well, like what an upsert is. So no, don't feel sorry. I appreciate the feedback. So yeah, that might be your answer. It looks like there might be some additional methods, or as from what I was reading in this top answer, it was built into the session.add So I'm sure there's some exception handling within that. And if you look up the SQL Alchemy, well, if you look up, you can look up SQL Alchemy or do the Flask SQL Alchemy. You can read into the documentation and check its code. So I'm sure you can find the different exceptions in there as well. So, but how about for the sake of, time and simplicity, we'll just say that the session.add has some built-in error handling, and it's probably, as Anton mentioned, it's probably in the when you specify whether a value is unique, because obviously the primary key has to be unique, and with an ID that auto increments, you're never going to have a repeated value, whereas the host name could be repeated, but because we put unique equals true, it may throw up an error. And let me just find declaring models. Hold on. Now you have me wondering. Oh, that was the one that didn't have any sort of documentation around it. Yeah, nullable was false, but I couldn't find anything specifically around unique. But unique's obvious; it's kind of straightforward. So, yeah, I assume there's some error handling whenever you set unique equals true. But okay, so we did it. We got the device in our database. There is a assumption that whenever we do .add, any fields or columns that we say have to be unique besides the primary key is unique. Otherwise, it would throw some sort of exception or error. So let's go ahead and add in the other device. Stream switch, get version. Done. All right, so this is a doozy. So I'm actually curious. I'm not going to count this off, but remember, in our database, in our model, we said a maximum of 20 characters. I don't know. I didn't count it off, but let's see if all of them are included. What's the last one? 949. Okay, let's see if 949 is included. Sure enough, and the parentheses. It had enough. It had enough to spare. So. So yeah, we're rocking and rolling. We got the database with the device table in it, and all the records. So, and this nice SQLite plugin is allowing us to visualize it. Now, if we wanted to, we could go into what I brought up before, the command line, right? So if we do .tables, you'll see device, and then this is where a little bit of SQL knowledge comes in. So you could do select star, which basically means select all records from device, which is the name of the table, and then semicolon. And you'll see here, this is the CLI response and what it looks like. And you can see this is obviously more nicely formatted and easier to search. Whereas here we can do filtering, but we'd have to use the where keyword. So with the SQL statement. So we're good. We got the database. That's all that matters. And I'm trying to think what else my plan was with this. So we have, we have the database. I guess next thing up is actually creating the API. Because as I mentioned, the API will, on the back end, use the database. It will pull records from the database and basically JSONify it, if you want to, consider that a word. And it'll present the user with a nice JSON payload that has all the proper information. And the way that we do that is using what's called a serializer. Now, Flask has this extension called Marshmallow, or this, I guess you can call it a plugin. But just reading it's pretty simple. it's a serialization library. And what this does is it allows you to interact with your, it creates its own models, right? And basically it has its own schema. It creates its own schema. And what the schema is how you want to format your payload, your JSON payload. So let's say we pull the user data out. I mean, you can see here, this is kind of what it would look like. I mean, you'd pull out a string value for hostname, a string value for version, a string value for date created. But let's say we pulled all this information out and we wanted to structure it in a different way or a different schema, where we have like the host name as the outer key, and then within that we had a dictionary, or in JSON, a JSON object, where we had the version and in this case maybe the date created, because we don't care about the ID still. The ID is literally just a primary key and special just for the database. I mean, I guess we could use it. We'll use it with the API maybe, but it's really not that significant because remember, users, you use the API to pull the data that you're looking for. And there's really going to be no one out there that says, man, I really want to know the database, the ID number associated with our router 1. It's very doubtful. So yeah, that's kind of next steps. And like I mentioned, we'll take a look at Marshmallow. I will say I have some experience with Sql Alchemy, so some of the things clicked as we kind of went through. But Marshmallow specifically, I don't have much experience with. So I definitely will take a look. I'll try to take a look before the next stream to make sure kind of we're on the same page with this. But the only other thing I wanted to mention was if you're like kind of mind boggled at this point, like, okay, I got database tables. Now we're talking about data models and schema and, what the heck. There actually is a library out there called Sql Models. And this is actually one that I'm using in my that net check project I keep referring to. And where it actually builds the schema, the data models, and the table models, right? So your table models for your database and the data models for your schema or your data, the structure of your data that can be presented, to a user via API. This SQL model library is phenomenal. So let me just see if I can show you real quick. I just want to show you a quick code example. And they actually added some. SQL DB browser. So I mentioned the very beginning before Clay brought up the VS Code extension that there was a piece of software that you can use to visualize your database. It's a little clunky, so I actually prefer the extension now that I've used it. But you can download it, and you can interact with your databases. You can do SQL queries. Everything's it's an all-in-one database browser. Let's see. Trying to find using the engine. Here we go. Trenchman, I'm late and probably missed everything. How's it going? Hey, I'm good. We're actually we're wrapping up here soon, but just to kind of highlight what we did, we created an SQLite database. And so now, and this is all the code that we added. So tonight wasn't really too much code. Oh, I guess we did add a little bit up here. We introduced Sql Alchemy, which basically allows us to talk to SQL databases with Python. And so we created a model here, a database model that allows us to mock up what a SQL table is going to look like in our database. So you'll see ours, the columns are ID, hostname, version, and date created. And all we did was we said, okay, well, we know we have the database table mapped out, and we have it kind of structured. Now we need to get data into it. And so all we did was we added a couple commands down here, some code that whenever we went through and added our host name or our new devices that we were pulling the iOS version, the software version from in the previous stream, we're now storing that in a database, and this is what it looks like. So you'll see we have our ID numbers, we have our host name, version, and then the date it was created. So that's what we knocked out tonight. I was planning on doing the API portion of it tonight as well, but we're running out of time. So will probably be next Tuesday's stream. Obviously next Thursday is Thanksgiving, so I won't be streaming, but next Tuesday I plan on streaming, and we'll do the API. We'll create an API that basically will read from this database and then present the data back to the user in a JSON format. So we're just kind of wrapping up, okay, how do we start doing that? And then I'm going over the Sql Model Library that kind of combines both creating a database model and a data model that we could use to kind of structure our data format. So this is a really good example right here, and I'm not going to go too deep. Like I said, I just wanted to highlight this. But basically what this example is showing is it's creating a hero class or a data model for hero, and then to double up as a table in a database, they have a parameter that's table equals true. So now you have in all-in-one class, you're able to define a data model. So basically how your data will be basically brought into the database, and then also how it can be extracted and then modeled to be put into, let's say, an API endpoint, right? Whenever an endpoint's called, how's the data structured? So this one particular class here doubles up as both. And it's kind of easier to read. The readability perspective comes from a library called Pydantic. And if you're not familiar with Pydantic, it offers type validation and type hinting. And if you're not sure what that is, I just suggest you go check out Pydantic, because this library, this module, SQL model, is built on Pydantic. So so that's all. I just wanted to kind of, now we've gone through the long way of doing it, I just wanted to show you that there are libraries out there that are making it easier. And on top of it, this library has a bunch of great intro to databases. It tells you what a database is, how to interact with it, all the great stuff. So very educational. Harshad says, gotta drop off now, but thanks for the stream, Dan. Good stuff. Keep it going. Hey, appreciate it. Thank you for sticking around. I really appreciate it. I'm glad people are able to take in the stream, and sometimes I feel like I start too low, very step one, but I think that's the best way to start. Otherwise, I plan on doing these streams till most likely, March, April, May timeframe, and so we'll be building on these skills as we go. We're just kind of starting off at ground zero. So Trenchman says, that's sick. Looks good for just a little bit of code. Did you have to do anything to create the SQL database, or does this also create it? I know nothing of database administration. So we actually were able to create it. We cheated and used a CLI command. So basically, it's not really a CLI command. It's within the Python interpreter. So we just we initialized the database, assigned it to a variable called DB, and then we used the create all method to create the database and the associated tables. So if you're interested, look up Sql Alchemy. Specifically, we were reading through Flask Sql Alchemy, and you can kind of follow the example here. Let me get to where we started. Quick start. And I'll throw it in the chat so that way you can kind of take a look real quick. Let me do that. All right, so I just threw it in the chat where the quick start guide, and that's pretty much all we followed tonight. It wasn't anything crazy. mostly because our requirements aren't that crazy. So, but that should give you a good start and kind of a better understanding of how it works. But to answer your question, it does create the table as long as you have the database initialized in the code and create a database model, which essentially, I mean, you missed that piece as well, but the database model essentially is like a database table, and allows Sql Alchemy does all the magic where it converts the Python code into what some SQL or something that SQL databases can understand. So that's kind of it though for that piece. So yeah, like I mentioned, Tuesday we'll get a head start on the API. What we'll do is we'll create it. We'll make sure it works by using a piece of software called Postman. I'm sure some of you probably know what that is. If not, it basically helps. It's a piece of software that allows us to test different APIs. Ours will be pretty simple and self-documented. Hopefully, we'll get that as well. But yeah, so thanks for kind of joining along with this journey. I know it can be tough watching someone struggle with a basic quick start guide. But yeah, most of my experience has been, especially with the creating an application that has an API, a web front end, and a database. I've mostly used Fast API and this Sql Model Library, which were actually built by the core maintainer is the same person. So like this and Fast API, Sql Model and Fast API are like, they just work so well together. And it documents everything for you. It creates the API docs, and there's a bunch of benefits more to the Fast API library than the SQL model. But yeah, so thanks for sticking around, everyone. Any questions in the chat? I'll kind of hang out for a minute or so while the chat catches up. But any questions you have for me or anything like that? In the meantime, I'll go to Fast API's documentation as well. Yeah. So this is just as a heads up. This is Fast API. This is kind of, think of it as like we're using Flask. You could also use Fast API to build the backend, and then the SQL model. Like I said, you could use SQL model with Flask as well. But it works just so well with Fast API. So that's kind of what I've done on another project. But all right, I don't see any questions in the chat, so I'm gonna kind of wrap it up. Next Tuesday, just housekeeping Tuesday. We'll be doing the API, creating the API for this. Thursday, won't be streaming. And then the following week, I actually will be out. I'm taking some PTO, so I won't be streaming the following week. But I'll definitely, if you follow me on Twitter, that's the best place to get kind of the latest updates. I'll definitely remind everyone on Twitter, probably towards the end of next week. But yeah, if you have any questions in the meantime, feel free to hit me up on Twitter at DevNetDan. And I guess I will be talking to you later. Awesome. Thanks.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays.